All right, the next one is the nth root. Now, this one is a somewhat new rule, kind of, sort of, not really, because I told y'all that if you have like an nth root of x, what are we going to change that to? We're going to change it to a power, right? So that is actually log x to the 1 over n, and then you just bring the power down. So while I've never really called out the nth root rule before, if something was, look up here, if something was this, we better know by now that that is the same thing as that. A square root is a 1/2 power, a cube root is a 1/3 power, and then we would expand that by moving the power out front. So it's really no different than the power rule, it's just that it's a fractional exponent. Okay, the next one is the multiplication rule. So what that means, that if you are multiplying a times b, one log with a times b, you expand that as log a plus log b. And then the division rule, I think you remember, is if you're dividing a divided by b, you expand that with log a minus log b. Okay, so we're going to do some basic expansion. So turn to the next page, page 36. We're going to do sum of number 1. Page 36, exercise 3B, number 1. Has everybody got these notes so I can change the page? Okay. All right, page 36. So they want you to expand log P, Q, R. Pretty easy. What are P, Q, and R doing? Multiplying. So to expand them, I separate them with a plus. Okay. Let's look at B. I have log P, Q squared, R to the 3rd. So I have product and power in this one. So I'm going to take it the long way around, then you're going to start seeing me just go ahead to the final. That's log P plus log Q squared plus log R to the 3rd. But that's not fully expanded. So it's log P plus 2 log Q plus 3 log R. Now, there are ways that you can check this. How many of y'all like checking your work? Okay, I do. I like knowing whether I got it correct. Now, this is not 100% mistake proof because if you just left it like this, it will check, but that's not fully expanded. So, everybody get your calculators out. And I want you to write this off to the side of your notes because you cannot store a value for P, Q, and R in your calculator. So we're going to store it, and P is going to be X, so you need to tell yourself this so that when you're checking it, you know which variable to type in. Q is going to be Y, and R is going to be Z. So you want to write those down so you kind of have like a, what do they call that, like a legend? Is that what that's called off to the side? Anyway, like a key, so to speak. All right, so store 5 as x, store 6 as y, and store 7 as z. And your x, y, and z are the ones that are 2 above the own button. You have some alphanumeric keys, but you don't have all of them, and I wouldn't waste my time. Okay, so up here, what I want you to do is you're going to type in log. Instead of p, we're going to put x. Instead of q, we're going to put y. Make sure we square it. And instead of r, we're going to put z and make sure you cube it. So do that, log x, y squared, z cubed. And tell me what number you get. I have no idea what the number is. What now? 4.79. Everybody's nodding their head. Okay, so 4.79 something. Now, type this in. That's your expanded form. So I'm going to do log x plus 2 log y plus 3 log z. And you should get the same thing. So while I said this is not 100% mistake proof, if you left it like this, I'm going to count off points because it's not fully expanded. But at least you'll know you're on the right track. You just got to make sure that that's expanded. All right, well, I want to skip down to D, because D poses a little bit of a challenge. Write it down for me. Now, what's the first thing that we notice here that's kind of some concern? That square root. But using the nth root rule, okay, I want to change this. Now, I've not expanded a thing yet. Is everything under that radical? Then everything gets raised to a what power? 1/2. So all I did was that I changed, oops, I didn't mean to do that. All right, let's do this, and then let's do that. Oh, it's super huge, that's the problem. Okay. I changed that to that. Haven't expanded a thing yet. Still not fixing to expand because I've got this power on the outside that I need to get rid of. When you raise a power to a power, what is the rule? What do you do to it? Multiply. So what's the power of this p? A 1. So 1 times 1/2 is 1/2. The power of the q is 2. 2 times 1/2 is 1. I can put it there if I want to. R's power is 1. When I raise it to the 1/2 becomes 1/2. I haven't expanded a thing yet. Now some of y'all can probably jump from this step to the end. I need to go step by step by step. So let's expand this. So that's going to be 1/2 log p. What do I put between the p and the log q? A minus. Log q. Now this is where it gets tricky. What's going to go right here? A plus, but not like this. That's wrong. Put parentheses around it, and then that will be acceptable. Or the other way to always write anything in the denominator is because when I expand this, so see I'm subtracting this whole thing. So I have to put this in parentheses. So that minus here, when I distribute it, everything in the denominator gets a minus in front. So you can skip straight to subtraction, subtraction. Anything in the denominator gets a subtraction in front of it. All right, questions on those? All right, I want y'all to do, let's just do a few of these. So, do number 1. I want you to do G, H, and let's go ahead and tackle I. Okay. All right, now take your phones out for a 1-minute break. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so finish working on G, H, and I for me. It's kind of like when you are adding or subtracting polynomials, when you add, it doesn't matter. When you subtract, you want to put that second part in parentheses. Yeah, so that you can distribute that negative. Yeah. So there's your G and there's your H. I'm not sure how many of y'all picked up on the log 10. If you did that in your calculator, do log 10 on your calculator. It should give you 1. Okay, so that's one thing that they're going to expect you to know. Okay, that log 10 is the same thing as 1. All right, any questions with G or H before I put I up there? Okay, let's look at I. Okay, so I'm going to change all of that to where it is to the 1/2 power. Now, I'm going to tell you if there's a mistake going to be made, it's going to be made right here. You're not going to separate the 10 and the P10. You do. But if a mistake's going to be made, that's where it's going to be made. So this is actually log 10 to the 1/2, P to the 5th, R to the 1/2, over Q to the 1/2. Each one of these has their own separate exponent. So this is going to be 1/2 log 10, which I'll take care of in a minute, plus 5 log P, plus 1/2 log R, minus 1/2 log Q. And the log 10 is a 1, and 1/2 times 1 just means it'll be 1/2 plus all those things. Okay, so any questions with the expansion? This stuff's not on your quiz tomorrow. Okay, I'll tell you what's going to be on your quiz on Friday, but this is not it. All right, so now we want to work number 2. So all we're doing on number 2 is we're writing it as a single, and then we're going to work it out. So you need your calculators. So 2a is 2 log 5 plus log 4. So you could stick this in the calculator if I was just asking you to solve it, but I want you to write it as a single first. So this becomes log 5 squared. What does the plus tell you I do now? Times 4. What's 5 squared? Times 4. So there it is as a single log. Put that in your calculator and tell me what the answer is. Okay, so that's what we're doing on these. So I want you to do B and D. Write them as a single log and then work them out. B, 2 log 2 plus log 150 minus log 6,000. So we want this to write it as log 2 squared times 150 over 6,000, which that's 4 times 150, 600. So what is that? That would simplify to, or 1/10. And that would be what? Negative 1. All right, let's look at D. So you had 2 log to the 4th minus 4 log to the 2nd. So that would be log 4 squared over 2 to the 4th, which is log 16 over 16, which is log 1, which turns out to be 0. All right, so any questions on those? Okay. All right, so we have some interesting stuff to do now. So why don't everybody just kind of stand up and take a break for just a minute.